This morning, John Huff and I, Jim Stottlemyre, are going to talk a little bit about using three-phase equipment in the home shop. And the first question is, what is three-phase? Probably everybody knows that as good as I do, but if you can see that top view is 110. That's what the current looks like in 110. You might remember that from high school, if you can remember back that far. And the second one is 220, where you have two different waveforms exactly opposite. Well, the third one down here, and it's not a real good drawing, but that's three-phase, where there's three hot wires. Most of us don't have three-phase available to our shop, so that's what we're going to be talking about a little bit this morning. This machine came from an auction, and John and I were going to talk a little bit about, if you go to an auction, what do you look at? John, you want to hit some of those points?
Yeah. Well, so you go either on the internet or you go to an auction and you see a piece of machinery sitting there, and it says, it looks like something you might be interested in, and you look at the tag, you check out the motor tag real quick, and it says 3 horsepower, and then you see three-phase, and you figure, I don't want to deal with it because that's just too much trouble. But you might want to take a second thought on that. And as you start to look at the machine, the first thing you probably want to do is give the motor a spin and see whether or not it actually rotates. Even if it's a little coarse or something, if it's just a bearing issue, you might want to give some consideration to keeping it to buying it, because bearings aren't terribly difficult to change, just a matter of opening the motor up. And most three-phase motors, 110 can get a little tricky in opening them up because they have switches and things in there that change your windings. But on three-phase, you don't have those internal switches and things. So that's something you want to keep in mind, is the bearing issues are relatively minor for a three-phase motor. Also, you want to check in, if you can, if there's any vent holes. This one, the vents are on the bottom. But if you can, get your nose in there and take a sniff. A sniff test works really well with the motor, because if it's burnt, you can tell. I mean, you can smell a burnt winding. Bearings don't trouble me as much as, or a stiff shaft, and that doesn't trouble me as much as a burnt odor. There's if you're looking at a piece of equipment and it's, it looks like it's been dropped off the back of a truck, you probably you might want to consider passing on that. So obvious signs of damage, like dents and bent shafts and things like that, are probably a little out of the range of what your average homeowner wants to do in terms of restoration. But if you can get a chance to look at some of the wiring and stuff, and this is a good example of wiring that's pretty worn. You see some of the threads. There's some tape in here, and you can see some junctions have been tied on. But if you'll notice, these are all these wires are fairly flexible. If you get one that's been overvolted and burnt, these wires will get crispy. And that doesn't mean that's an absolute no, but that'd be a warning sign to me. I have found some things with crispy wires that you can repair, but that's something you want to be real careful about, and the price ought to reflect any damage like that you find. So in terms of just a quick overview, that's kind of some of the key points you want to hit. And also, I'd be nervous of shiny stuff, stuff that's been clearly slap painted real quick. If you see lots of overspray, this is a pretty typical of industrial equipment that gets, they have an annual shop cleanup day, and they get out there with a paintbrush and paint away. But if you have something that's been shined up and clearly put out for sale, that's something you want to take a little extra time to look it over closely. But very often, ratty looking stuff like this can come at a great price and can be a great addition to the shop. So
yeah, one thing that I always look at in addition to that is there's a motor plate on here, and it'll tell you the voltage. This one's 220, 440 probably. Yeah, 220, 440, which is good. If you get one that says 380 or just 440 by itself, or even, what do you have, Vern, 580 or something?
580.
you're talking about a lot more expense than getting that running in your shop. I don't have anything that's 440 only. All the stuff in this shop has been rewired to 220, 240, whatever you want to call it. So one thing you got to consider when you're buying this equipment is moving it safely. This one's not too bad. John and I could lift this one up by ourselves if we had to. Some of the three-phase equipment you'll get is going to be heavy, so you have to plan. That's one of the considerations when you buy it. How are you going to get it home?
Call Jim.
Yeah, but you'll need, sometimes you'll need equipment like an engine. Thanks, guys. An engine hoist, or a pallet jack, or a trailer. John and I went to pick one up. It was advertised as being 80, yeah, whatever it was. It was advertised being less than 8 foot. And we showed up with an 8-foot trailer, and they hadn't measured it exactly right. So we had to borrow some planks to lay in the trailer so that the front legs could be in the trailer and the back ones were hanging a foot off the back of the trailer, just sitting on the plank. But you'll need a way to tie it down, and you'll have to remember, some of us just can't lift 200 pounds anymore. You gotta, unless you want to pay for it for the next week or so, you need some friends. So, there you want to talk about why you would even want to buy a three-phase piece of equipment.
Yeah, that's good. That's a good point. I'd say probably the biggest reason you want to do it is durability and basic reliability. It's stuff that was built, to run 24 hours a day, 7 days a week. It's some of the toughest industrial machines you'll ever find. If they can put up with that kind of stuff, there's nothing you can do to it in a short period of time that you'll have it that will wear something like that out. So I think that's probably the key issue with three-phase. The other part is when you go to an auction, two of the things that kind of start to lower price when you go to a general auction, if it's a 110 volt piece of machinery, that goes premium price. If it's 220, the price starts to come down. If it's three-phase, it comes way down. They usually cuts by half, from 110 to 220, and 220 to three-phase drops it even further. So price is a big issue when you're looking at three-phase equipment at auction anyway. And I think another, aside from it being inexpensive, and this is a good, I think my lathe is a good example of that, is that we found that blunt lathe, and that was a three-phase, which scared me away from it initially. But the other thing that got me was the weight of the item. So weight can be a negative, but it can also be a real positive, especially when you're talking about vibration. So vibrations in machinery transmit to the product that you're doing. It doesn't matter if it's a table saw or if it's a lathe, you're going to get that vibration will transfer through to the product that you're producing on it. So heavier is better in that regard. You also get a larger capacity, generally speaking. Most lathes are 12-inch. Most industrial lathes start at 12 and get bigger. So same thing with saws. You had 10 inches generally your average on a saw, but as you start getting into the industrial stuff, you start getting into 12, 14, 16-inch saws, and those are incredible. It also means that when you get into the three-phase equipment, since you have 3 wires going in, the wires don't have to be as big for the amperage that you're having. So if you have a let's say a 2 horsepower, 3 horsepower, 10-inch table saw that's running on 110, you're looking at somewhere like 18 amps. If you have that same saw in three-phase, you really split that by 3, so you can divide that. You're 6 amps per wire, so your wire size can go down to that 6 amp thing instead of the total 18 amp, which would require some much heavier cabling. So, and additionally, they also run cooler than a 110. So, those are some of the.
Oh, that cool was your.
Yeah, oh, I wish that was cool.
Yeah. Okay. Yeah, that.
Turn the heat off, dude.
I just did back here. Of course, if there's pluses, there's negatives, and the first negative is fear. People just get scared when they hear the word three-phase. But a lot of us have three-phase equipment in our shop right now and don't realize it. Your big Powermatics, Jets, Grizzly, this VB, the Robust, they all have three-phase motors in them. Now they're not advertised as three-phase because they've got a variable frequency drive, which we'll talk about in a minute, but they are three-phase. I was looking at that Robust this morning, yesterday afternoon, I don't remember which. The motor plate is way down underneath where it's hard to see because they don't want people, oh, that's three-phase, I don't want to buy that. But you get down there, that's a three-phase motor, and it's got a variable frequency drive on it so that you can just plug it into 220. And that's where we're headed with this today. But there's a couple, there's different ways to convert, and we'll talk about that. But one of the things we said before, a negative is a weight. They're going to be heavier. They're going to take up more space. I don't know if you guys can see this little grinder here. Some of you can. It's a 8-inch grinder. That's what most of us would have as a bench grinder in our shop traditionally. If you look behind Joe there, that grinder is a little bigger. It's going to take up more space. The wheels are going to, instead of getting a wheel for $10 or $12, you're talking $100 to $200 a wheel if you buy them new. So you got more expense in that kind of stuff. And the other thing, if you go to change those wheels, you're not going to do it with your standard 3/8 inch socket set. You're going to have some bigger tools, which in my mind, that's not a negative. I'd like buying tools anyhow, but so there's some things, there are some negatives to them. But we've got several options on taking this. This is a three-phase 220 sander, and the options we have on changing this over, one is a rotary phase converter, which that's what I use in this shop. I've got wired and back in the back, if we can reach it with that. Now I've got live three-phase throughout my shop. If you're going to have a lot of machines, that's the way to go. Because it's one expense, and you're not spending $100 a piece to put a variable frequency drive on. The second option is a variable frequency drive, and that's, we've got one right here, and those of you that's got a Jet or a Powermatic, and does Grizzly hang theirs on the outside? Yeah. So you might have seen something like that. That's what it. About the same company. Yeah. That's what they look like. Wonder what those two wires get to. Another option is change the motor. If Lee's probably not happy with that option, but if you can get something like a bandsaw or a lathe or a drill press that has a standard size motor in, and you can find a 220 or 110 volt motor with the same frame size. Frame size will give you the mounting pattern. It also gives you the shaft size. It gives you the distance from the mounting pattern to the shaft. So if you hit the same frame size, you're going to be able to just take one out and put the other one in, which is a good thing. You might have to change the switches and stuff to match single phase instead of three phase, but that's a good choice. And for those people that are lucky enough to live where three phase is available, which it's not here. I don't know if anybody has it available at their. Do you have three phase at yours from the street, Nelson? No. I mean, that's an option too. My neighbor had a little shop, and three phase is about 3/4 of a mile, and I think they wanted $15,000 to run the wire to him. That was 30 years ago. So that kind of puts it out of my price range. In this shop here, we have, I have a number of machines that are running on three-phase, and I think the number is 8 of these different machines you see throughout the shop are three-phase. Plus, there's 3 in here that are three-phase with the VFD built into them. This lathe, the robust, and a little tool we'll look at later, a sander that we made. So that's why we went that way in this shop as far as the rotary phase converter. But this one, a lot of people are just going to have 1 or 2 machines, in which case the VFD is the best choice for a couple reasons. First, it's quick, easy, and relatively inexpensive, and the V part is variable. What that means is that it's going to, this is running is designed for 60 cycles, which is what we've got in the US, and the variable frequency drive will vary the number of cycles. So if it puts it at 30 cycles, this machine's going to run half speed. If it puts it 120 cycles, it's going to run double speed. So you can, you've got a big choice here. What I do, first thing I like to do, and it's not an option for everybody, I think we did it with your lathe, is before you put a lot of time and money in it, let's just see if it works. And you can do this even before you buy your variable frequency drive if you've got a friend with a rotary phase converter. And what I'm going to do now is just hook this guy up to a little switch I have here, and we're going to test it to see if it does in fact work. Oh, I hope it doesn't hum. Okay, so hand me that controller. We're almost the limit of my reaching the. So we've got it hooked up, and I'm just going to turn this on and off to make sure you're ready, John.
Yep. Let it run, Jim.
So
I see your switch is on. You have
well, that switch, Joe, I've got it disconnected. I took the switch out of the circuit for 2 reasons. First, just to save us some time this morning, and second, most variable frequency drives recommend that you don't switch the current coming out of them. That if you want to switch them, you switch the current going into them. So that's why that is like that. All right.
Well, there's something we didn't talk about was the advantage of a variable frequency drive in terms of the type of machine that you're using. So if you're putting it on, say you bought a 3-phase drill press, that gives you, instead of changing your belts for your speeds, it allows you to change the speed based on the drill bit that you're using. So instead of just doing each cutting tool has a feet per minute. So instead of just going with an average, which is what a 4-speed pulley would be, or a 9-speed pulley setup would be, you can dial it right into the exact feet per minute that the drill bit calls for. So you could, and the same thing is with a bandsaw, you go variable speed in the bandsaw. If you're into metalworking, that works. And for sanding, feet per minute is important too. So if you'd have to get into a little bit of the literature that the abrasive companies send out, but lots of them will recommend a specific like 1,200 feet per minute for their particular belts. So if you're running a you know, 3450 RPM motor with a straight belt right off that, you might be getting it somewhere in that 6,000 feet per minute belt range. And at that point, you're burning wood very quickly. So if you've ever burned wood on a belt sander or turned a bit blue on your drill press, that might be because you're running either too fast or
And you're talking also 110, or not?
No. You can't put a variable frequency drive on 110. That's the sad part of it. Unless it's I think there's some DC motors that you can do that with. That's the only thing I'm aware of. That and universal motors can be done with variable speed, but generally speaking, the only one that can run is old 3 phases off of frequency drives.
Yeah, the way they control speed on other ones, of course, we remember the step belts that many lathes had. There's also a Reeves drive, which is variable width pulleys that we've got one in here. I know the other people have them. Lee, that's on your Grizzly. It's got a Reeves drive.
They're much they're noisier and you get a lot of vibration to transmit.
Yeah, I showed Larry Whitmer my jet lathe that has that.
Okay, as we said, this is a variable frequency drive, and they come with a manual that, if you're not going to do anything special, is pretty easy to follow. I was having trouble getting the right settings on this one, and what language is the manual written in?
Taiwanese or something.
Chinglish, I think, or something, and it just doesn't read well. So I looked on the internet, and the first 2 people that I looked at said the manual's great. It's got everything you need. And then you watch what they do, and they hooked the input and the output wires up and flipped a switch. Well, yeah, it's great for that. If you want to program it, which is it's not difficult as long as once you understand it. These are programmable for a number of functions. You can program your speed. You can put preset speeds in it. You can program. Did you notice when we shut this off, it just drifted down? This one's going to be programmed to break it, so it'll stop it quicker. You can program the ramp up speed, the ramp down speed. If you're going to do great big bowls on a lathe, you normally don't want it to break real quick, unless you've got your chuck locked to the spindle real good, because you can just break it. And there's a number of us that have tried that. You
I had a great big metal
and me,
8-inch chuck come.
Yeah.
Right off the end of the spindle, so I can get dicey on your toes if you're not paying attention.
So there's a number of ways you can put a remote control box. This has a removable control box. You can put an extension cord on and mount this little panel somewhere. You can control it all from everything from this panel. What we're going to do today is we're going to wire this up, and we're going to put a remote switch in it. That's what these 2 little pigtails are for.
And I think on price point on these things, the cheaper the VFD, generally the less interpretable the instructions. So the more expensive ones get better manuals, they have better instructions, they have better customer support. And there's just a wide range of price in VFDs. That I think that was like a $75 one. They can go as low as like $60 all the way up to about $400. So depending on the horsepower and stuff. But a lot of the price has to do with the instruction manuals, how readable they are.
Is there a brand that's more preferable than others?
No, there's a club, a website called Old Woodworking Machines. They tend to like Teco and Automation Nation, so we're not going to pay for that. But they're the guys that they tend to recommend the most. I've never used them, so I really don't. I can't speak from personal experience, but they seem to get a lot of press, and people seem to be pleased with them. So I don't. There are some American companies that make variable frequency drives, and some of those get pretty pricey. I think the one that's on my lathe, the big blunt lathe, is a KDAC, so that's KD Electronics out of Florida, and of course they're manufactured in the U.S., so all their instructions are U.S. and their tech support is U.S. based. So if you're having, if you're I guess a little, if you're new to all that stuff, you know, the better tech support you get, the easier it is. And some of them are very programmable like this one, and then others are less programmable that are marketed more for the farm market, and some of those kinds of, that's how I got into the thing, was through one of these Mennonite electric shops that you know, does conversions for farm equipment and restaurant equipment, and their big selling point was like farmers don't want to mess with, you know, having to work through all these different functions and stuff. They just want to plug it in and kind of use it. So they, instead of using programmable stuff, they use jumpers. You can just go in and switch the settings. You know, and it's just, I guess if you're a programmer, that's very familiar. If you're a mechanical kind of guy, jumpers are more familiar. You know, so they market, you know, to their, I guess, to their customers. So that makes good sense. Depends on. It really depends on. I guess your budget. If you're unfamiliar with the jumper wire stuff, it's easy to deal with. But once you've done it once, I have to say, it seems it's all very mysterious and everything. Once you've done it once, the basic issue is 2 wires in, 3 wires out. You know, so it can't get any simpler than that. It's really hard to mess it up.
The biggest thing they say you can mess up is putting the live wires in the output and the output in the live wires. That's bad. It will fry it immediately.
Put your fingers and stick them in, you'll know, you know. I was intimidated by VFD the first time I went around. And like I said, that's one of the reasons I went with KVAC, because they were, you know, less intimidating in this realm. But the truth is, they're fairly simple. I don't think it's beyond anybody's capability, you know, working through one of these things.
So I've just, in that amount of time, wired. We've got two hot wires going in, three coming out, and I put this switch in there. And you clear?
Yes. Yeah.
We always try to be as safe as possible. Okay. I just plugged it in, and I've got a display there, which I have no idea what it means, but we're going to turn this switch on and see if it turns on. Okay, that's running in reverse. To change that for a 3-phase, all I have to do is change 2 of these leads, and it changes the direction. Or if I was so minded, I don't know if I can. Okay, I've got this plugged into a start forward, so it thinks it's going forward. I'd have to change 2 of the wires and it would be fine. But I can adjust the speed, and I can stop it. You notice how quickly it stopped there. That's got the brake on. So right now I've got a usable machine, and the things I did with what they call the programming was these come. Most countries in the world use 50 cycles, and these are all everyone that I've played with comes preset at 50 cycles per second. I change it to 60, and it asks you, there's an option on, do you want to control it with the keyboard here, or do you want to control it with an extra switch? You just hit the option for the extra switch, wire the switch in, and you've got a usable 3-phase machine. Yeah, John was saying the price. This one, there's a couple things that affect the price. You were talking about American made. That really affects the price. The other one, the bigger units you get, the more, in general, the more money. There are some exceptions to that, because they've got 3 horsepower ones now are cheaper than 2 horsepower ones, and it's probably due to the volume. But the important thing is the amperage. This one is good for 8 amp, and this motor draws 8.4, and that's close enough for me. If it draws over 8 amp, this will shut it off. It acts as a motor protection, which supersedes your a lot of machines, 3-phase. What I've got have a heater, what's called a heater. It's a little fuse in it that protects your motor. You size that to the motor. This you size the motor to. Since it's 8 amp and this is about 8 amp, I just left it go at the overload protection at 100%. If I was to use this unit on a motor that only drew 4 amps, I'd reset that to 50%. And then I've got the motor protected. Our fuse boxes or circuit breakers, they're designed to protect the wiring in the shop or the house. Your wiring, depending on the gauge, you have a maximum breaker size you can use, which in this case, I'm running a lot bigger equipment than this off my 3-phase. That bandsaw is 7.5 horsepower as opposed to 3. So the wires are sized so I can run that bandsaw, and that circuit breaker is not going to kick off on this machine until it's already fried. So that's why you like to have the additional protection. So this gives you variable frequency drive, motor protection, your braking power, and this unit, when I bought it, it was about $100. I think you can get them now for somewhere around $70.
And the other thing was that one's set. This one's a 220 input VFD, and most of them are 220 input. But there are some 110 input ones. So, you know, that's another thing to keep in mind is that they're a little rarer, and oddly, I think they're a little bit more expensive. But usually the correlation is the higher the amperage that you're drawing, so the bigger the horsepower, the more expensive the VFD. So if you're in a 3/4 horsepower range in that, or 1 horsepower, that's a price point that's in that, you know, less than 100 and below, probably no less than 60, I'd say. But that's that first step, and then you know, up to probably 2 horsepower, then you get close to 100, 100.5. If you get up to 3 horsepower, that's where you start to get 250, 350 into that range. So the bigger the horsepower, the more expensive.
You're talking
VFD.
American price, made price?
Just in general.
Well, because this one is a 2 horsepower
Okay.
for 70,
Yeah.
and you can get a 3 horsepower for just about the same price, $63, $64.
Shop around because
Yeah.
you just never know.
And so far I've
The
been,
input voltage is what I was trying to make. A
Yeah,
point of,
the
is
in-
that
the input
there is
voltage-
Some 110 volt input VFDs, but they're not the norm.
okay, anybody have some questions? Vern, have you been biting your tongue?
No.
Okay, good.
The only thing I came across is get a cheap ohm meter from somewhere,
I'm gonna check their
and
amp
before
draw.
you put the power to it, ohm everything to ground.
Well, I did that. I didn't mention it, but
Well,
I got it wasn't a cheap ohm meter. I have what's called a mega ohm meter.
people-
And a mega ohm meter checks the motor insulation, and it's this one checked out real good. It went off the scale at the high voltage, so I'm good with that.
That's a good point. That's something I didn't think about. But if you set one of those up, one thing you want to make sure you do, even though you have a ground to, you know, your regular ground wire there, you can see it coming from the 220 in. So the green wire is your ground wire. Whenever you set a VFD with a motor, that's not enough ground for it. You need the ground. You need to bond that unit to this motor, because VFDs do weird things with frequency field, and there's some voltage bleed sometimes. The first one I set up, I had set it up, everything ran perfectly. I was happy as could be. I'm running the lathe, and I had my hand I think I had my hand on the tool rest, and I reached over to do something, and it just brushed the edge of the VFD case, and I felt a tingle. Well, I felt that tingle before, and I kind of like backed off and, you know, turned everything off, and then I took an ohm meter on it, and there was about 60, 70 volts, so it was running hot off the frame of the machine.
You mean you took an ohm meter from what now?
From ground to the case.
To the case?
Just to
okay.
check to see, you know, if there was any voltage there, and it was hot. So You know, that really surprised me. And then I started digging. I thought, oh, I got a loose wire. I opened the motor up. You know, I'm looking at all the wiring and stuff like that. And as I dug around and talked to some electricians and stuff, they said, you know, did you bond your VFD to the machine? I said, well, no. Why would I do that? It already had a ground wire there, you know. And the odd part was I had originally set up to do that. I had a pigtail set and everything. I just didn't do it. And I don't remember why I didn't do it, but after I set the ground there and then I did the checks, you know, everything was clear. So if you do install one, make sure you bond that unit to your frame so that everything is grounded and bonded.
See, I have one I'm doing right now that with my buffing machine, just a 110 just sits there, and I get shocked once in a while, so maybe I should ground the...
Definitely do that, and I'd be looking for cracked wires. If I had a grinder that did that, it was a 110 grinder, but when I turned it over and opened everything up, you know, all the insulation's cracked because it's old, and it was just bleeding over the frame. So you start looking for cracked wires on 110, but these bleed from the frequency. I mean, it's an odd. It
induces voltage into the metal around it.
Yeah, it's really weird. They're strange, but they're cool.
Yeah, a lot of these older machines, you'll find they don't even have a ground wire on them.
Yeah.
They were just wired 3 hot wires and that's it. I have not run across one yet that it hurt grounding it. So they might be out there that there'd be a problem, but I've grounded just anywhere. You're right, John. Dan, you had a question?
Why did you choose to stick with single phase on your bandsaw rather than a phase converter?
The bandsaw is on the rotary phase converter.
Oh, okay.
Yeah.
And that's 7.5 horsepower. So a 7.5 horsepower variable frequency drive would be like crazy expensive. Yeah, it'd cost as much as the bandsaw did. Well,
from
that
me,
bandsaw.
yeah.
Maybe not that bandsaw, but it's they get really pricey when you get above 5 horsepower. So I think 5 horsepower is probably the cutoff for practical. Then you really are starting to talk about buying a rotary phase converter for it. And even they're not cheap. So unless you make it yourself, that's another.
Yeah,
That's another
show.
adventure.
I have a 110 with reverse frequency converter.
110N?
110.
What's
A 110 or 220.
is it 110 in, 110 out?
No, 3-phase out.
Yeah, it's 220 out.
Well, okay.
Yeah, you can get a phase converter. In fact, the one that Vern brought in is 110 out, 10 in, 220 out. It's the 220 out that we were talking about. The motor has to be a 220 motor.
I'm running a 3-phase Powermatic Model 90.
Yeah.
A 110 converter.
Right. But if you look at your motor tag, I'll bet it says it's a 220 motor. I think your phase converter is giving you the 220. That's what I'm betting.
I have a 110 inverter that takes 110 power in and then converts it to 223 phase on the output side. So that's
I'll have to look at it.
yeah, that's pretty. They're out there. They're not as common as the 220 ones, and they're a little bit pricier too.
Yes, they are.
Why would you have a 220 converter hooked to a 220 motor? Why have a converter other than variable frequency?
Phase.
I had to do it to run the machine.
That's phase. It's the phase issue to generate that third leg. So remember, you're talking. So there's 110, there's 220, and here's 3-phase. So when you need to generate that third phase, and that's what an inverter does, is the inverter does 2 things. It converts, and for yours, it steps up the voltage, and then it generates a third leg. So that gets you that 3-phase power. The other ones, the 220s, they'll take the 2 in and generate the third. But in yours, it's going in at 1 and generating 3. So
I did that reverse right on it. I don't have to rewire it.
No,
right. And that's
no,
the
you don't have to do
cool thing
anything.
about this. You can just flip a switch and go to reverse on it.
Yeah.
Yeah.
Anybody else?
So most of those VFDs have a grounding lug in them?
Yes, the VFDs have a
Instead of running a 3-wire circuit like you got there, you'd run a 4-wire, one
Yeah.
would be your bonding wire.
Yeah, if I was going to run this
separate
machine with this, I would do a couple things. I would put this this control unit in the cabinet down here, protect it from dust, mount the switch, and I'd run a 4-wire, and it doesn't have to be heavy for 8 amp. I know this sounds too light, but the book says 8, what did I say, 16 or 18 gauge?
It was light.
Yeah, but I'd probably run either 14, maybe 14 gauge wire, just because I like to have enough wire.
Pocket ring fire here, that must be important, it's done about a dozen times. There it goes again.
All right, anything else? Well, if you think of anything or you need help, John's available most of the time.
And you're available all the time, okay?
Okay. All right, thanks guys. That's it.